Okay, so we're going to now move on to part 2 of session 1. I hope that that exercise that you did at the end of the last session gave you an indication of just how variable data, normally randomly generated data, can be, particularly we'll find with small samples. But we're going to go a little bit further now, so I'm going to share my screen. Onto part 2 though. And we're now ready to actually simulate a study with the two-group comparison. So what you can see here, I've created some z-scores, and what I've done here is simply combine the two steps that you had, because you first of all generated a random number with the formula rand between 0 and 1, and then in the next step you used norms inverse to turn it into a z-score. But you can just combine them. So this looks rather a horrendous formula, but it's the quick way to do it in one step. Get a load of z-scores, and then you can just randomly, or actually not randomly, systematically here, assign the first 5 people to one group and the next 5 to another group. So here we've got one over here where I've done this. So let me just insert that group. It's always a bit difficult when you lose all your columns. So I'll put group in here. So here, these are created with that formula, norms inverse random. So you've got a load of z-scores, and I'm just going to say the first 5 are all in group 1, and the second 5 are all in group 2. Let's just tidy it up a bit, make it a bit less all over the place. Right, so now here we are, we've done that. And I've put here congratulations, because you can say if you've done that, you have simulated a data set. It's a very small data set, it's not a terribly exciting data set, but nevertheless, this is what simulation is. You've just used the random number generator to make 2 little samples, both drawn from a null distribution with mean of 0, standard deviation of 1, normal distribution. So we can do some statistics on our simulated data. So here's the simulated data, and this is the formula for just getting a mean out of each of the groups. So just show you there, we can say the average. For some reason, Excel doesn't have mean, it has average, but that's all the ones in group 1. 6.2 in my sample. What about those in group 2? 0.88. So this is already, again, I hope, slightly illuminating and possibly even surprising. I've put here in my next slide, are you surprised at what you see? The means, they're different in this example, they'll be different in your example, but it's rather unlikely, in fact, that they'll both be very close to 0, even though you're actually simulating numbers that should have from a population where the mean is 0, because that's how it works with the way we've simulated them here. These are normally distributed data with a mean of 0 and a standard deviation of 1, these z-scores. And yet you may see something quite a long way from 0. So it's worth taking a moment to think about why that is, and why, although you've plugged into your simulation a mean of 0 as the thing you're working to, you don't see that. So what I've suggested is that you get a sense of what's going on if you repeatedly press this calculate now button, so you're changing your random numbers every time you do it. And what you'll be seeing is this variability from one run to the other. And this is a very key point in statistics, which often people are taught about it in a sort of mathematical way, or just told that samples differ from populations. But this really brings it home to you when you simulate data, that these samples are going to be very, very different. So if I just keep pressing calculate, my head is in the way, but go back to home, go to formulas, calculate now. You can see that they hop about these two means all over the place. Sometimes one of them's quite close to 0 and the other isn't. Here they're both negative. Here one's about 0.5, the other's close to 0. But this is just the way simulated data behaves. It's when you've got a small sample, like just 5 individuals, as you can imagine, any one of these that by chance happens to be very big or very small can exert a very big effect on that mean, because it's such a small sample. And this is the danger of working with small samples, is that they don't necessarily give you a very good indication of the population mean that you're talking about. So if we go back to our slides. Now, you can now do a t-test on your data. You've got everything you need. You've got 2 little samples. And we can say, there's a formula for a t-test in Excel, which I've put in down here. And one of the key things when you're doing any sorts of coding or programming or simulation, you'll keep finding things where you don't remember what a formula is, or you don't necessarily understand it properly. Just Google it. Any good programmer is on Google all the time, even if you've been doing this sort of programming for a very long time. I mean, as you go along, you keep thinking, I can't remember how I did this, but there's tons of help available online. And that's the joy of these days, being able to just very quickly get help from all over the world. And everybody, most problems that you encounter, other people would have had the same questions. And so you just Google them and you'll get an answer. What you find if you Google for the t-test formula in Excel is it has t-test, and then it gives you the 2 ranges. So this is these scores. They happen to be in column H on this occasion, the first 5 and the second 5. And then these 2 numbers, a 2 and a 2. The first number tells you whether you want a 1 or 2-tailed test. And then the second number is whether you're doing a paired test, an unpaired test where the 2 groups have equal variance, or an unpaired test where they have unequal variance. You don't need to worry too much about that at the moment, but we'll see later on, this can assume quite a lot of importance in terms of affecting the sorts of results you get. But what this formula then just spits out is a p-value. So it's the probability that there is no difference between the 2 groups, that the null hypothesis is true. So you might want to try just typing that formula in. I'll do it here. In fact, yes, it's not, in my case, this is column C. So I'll go, let's see, where did I want it? Down here. So we'll do t-test, but it will be equals t-test. So it's this first little set of numbers, C2 to C6, and then the second set of numbers. And then we'll do that 2 for 2-tailed and 2 for unpaired. And so I have a non-significant p-value of 0.203. So let's just carry on though. You might start to think, why am I bothering to tell you any of this? Because we've now generated normally distributed values with a mean of 0, standard deviation of 1, z-scores, for 2 groups. And we've shown that on a t-test, they don't differ. So you might think, well, why is this interesting? Well, the thing is that sometimes they do differ. You may have actually got a p-value less than 0.05 already. And what you'll find with this next little exercise is that this will happen, that despite the fact you've generated your data completely as basically noise, every now and again, a significant p-value will pop up. So I'd like you to try this just with your simulation set up as it is. Just repeatedly press calculate now and try it 40 times and keep count of how many times you get a p-value less than 0.05. But before you do that, have a think as to whether you have any expectation about how often you should see that. And then we'll come back and think about that further after you've had a chance to try that out. So I will now leave Zoom.